Hey everyone, and welcome to this session recorded for 90 Days of DevOps. I'm Michael Cade. I'm a field CTO at Veeam Software, but that's got nothing really to do with what we're about to talk to. So, first of all, our focus for this session is about Talos, which is a Linux distribution focused on Kubernetes, as well as running that on VMware vSphere. There are other options, and we'll get through to that as we walk on. There is a bit of theory. What is Talos? What is VMware vSphere? And then we're going to get into actually deploying a brand new cluster into our vSphere environment. Okay, so things that we want to cover is what is VMware vSphere. I come from an infrastructure background. I come from a virtualization background, so I'm familiar with that. But I know that a lot of people maybe aren't. So let's very much look at that from a 40,000 foot view. Then we're going to look at what is Talos. One of the things that I've found since I've been posting about Talos on Twitter and around social media is, what's this? And lots of questions. So I wrote a blog post, and now we're looking at this session. Then ultimately, well, why are we bothering to do that? Hopefully I'm answering that as we go through. Then we'll get into the demo and then finish up with some next steps and what my plans are around Talos in particular as we move forward. So VMware vSphere, for those that are not familiar, is probably the most adopted virtualization platform that we have available to us for on-prem virtualization. Don't get me wrong, we can run virtual machines in the public cloud, EC2 instances, Azure virtual machines. We can also run VMware up in those clouds as well. I would say a large majority of the people that I've worked with over the last 15 years have some skill set when it comes to running VMware vSphere and the surrounding technology around that provides us the ability to run our virtual machines, provide high availability, and all of that good stuff for when we want to run our VMs on our bare metal physical servers in our own data center. It allows for us to get quite a resource efficient way of running those machines in there, and probably the biggest platform of where we're seeing most of our workloads today out there in the field. So why are we considering running why are we considering running Kubernetes on VMware at all? And this isn't Talos focused, but over the last few years, VMware have announced and actually purchased Pivotal, and really the benefit of running Kubernetes on VMware isn't necessarily running their own VMware Tanzu and their different flavors of that, but ultimately being able to run or orchestrate containers or have Kubernetes alongside those virtual machines. And one thing to note here is that we are actually seeing virtual machines within the Kubernetes construct or within the Kubernetes API, which I think is a very interesting take as well, right? Being able to use a project called KubeVirt. I'm not going to get into too much detail about that. Maybe that's another session. A lot of people have already made that investment, that capital expense on a lot of the hardware that lives in the data center. Not everyone has a credit card in the cloud providers, so they can spin up, spin down. They don't really care about the underpinning architecture. So this gives those people the ability to integrate their infrastructure, their spends that they've made around virtualization that they're predominantly using today, to also run and start that Kubernetes journey. Also, one of the things that we want to touch on in this particular Talos story is about automated Kubernetes setup. How can I get a bunch of virtual machines up and running ASAP and serving as a Kubernetes cluster in not much time at all? For some, GUI-based management, I've got that twice here, I'm not sure why. But GUI-based management gives us the ability to obviously see that. There is a lot of CLI or API capabilities that we have as well. And then also, how do I run Kubernetes in an air-gapped situation? Now, that could really be any platform, but it's something to mention from a VMware point of view. Okay, so how do we communicate with vSphere? And there's many options. There's that UI that I just mentioned. There's also something called PowerCLI, which is going to use PowerShell. But then there's Govc and GovMoMI, which is a Go library for interacting with VMware vSphere APIs, and that's both at the ESXi layer. So if you think about nodes in Kubernetes, the ESXi is almost like a worker node that is going to run our virtual machines, and then vCenter is our control plane. It's going to handle and manage all of the virtual machines. If one of those ESXi hosts die, it's going to bring that virtual machine up, providing it's on shared storage, onto another host within your cluster that has the available resources. So many options. Today, though, we are going to focus on Govc. Govc is what we're going to use to at least deploy our underpinning virtual machines that are going to act as our Kubernetes cluster. So what is Govc? It's an open source project with over 2,000 stars. I think last time I checked it was 2.2. It's statically compiled. It's a statically compiled vSphere CLI built on top of that other project that I mentioned. It's written in Golang. It's compiled for all the operating systems, Linux, BSD, OS X, and Windows. And it's a very user-friendly CLI and a great alternative when you're trying to get stuff done at scale and fast. It's a great alternative to the GUI. And in fact, in the Kubernetes realm of vSphere, I've actually seen some areas, especially around PVCs and first-class disks, which is what they're seen as within vSphere. There's some areas where only Govc can provide me the information versus actually going into the UI, which I thought was quite interesting in itself. Okay, so what is Talos? So let's think about Talos Linux as an API. It's API managed. It's declarative. It's a minimal Linux for Kubernetes at the very high end, and really why that's beneficial is that we can spin things up. We can spin things up very fast. It's very consistent. Talos isn't just for vSphere. Talos can work pretty much anywhere across clouds, bare metal, on the edge. Really, virtualization, it's not just vSphere. We can run it on VirtualBox. We can run it on KVM. We can run it literally anywhere. Probably the biggest feature of this is the security by design. If I just go over, so 3 areas and really what I want to touch on is the security part. Secure by design. It's a very tiny binary. I think the last time I looked at the ISO, it's like 40 meg. It's a hardened Linux, and it's purely only running certain binaries to get us up and running. Minimal image-based OS, like 50 meg image. Like I said 40, but yeah, 50. It's very fast to boot. And it gives us that minimal attack surface. Now, why not Ubuntu? Ubuntu works absolutely fine, and you can do this pretty much the same way using Ubuntu. But what you're going to have there is you're going to have things like SSH. It's going to be a much larger image. It's going to have a bigger attack surface. The other thing is around predictability, so eliminates the configuration drift. Reduces unknown factors by employing immutable infrastructure ideology, so it's not going to allow you to change certain elements of that. Evolvability, I didn't even know this was a word, but this is all from Talos' site. And it really simplifies your architecture, increases your agility, and always delivers current, stable Kubernetes. One thing we're not going to get into here is the ability to upgrade your Kubernetes version. One thing you'll see in the demo is that it's great for deploying a certain version of Kubernetes, but then it's also very good at bringing in the new version. It really hits the easy button, or the easier button, when it comes to that. So before we get into the demo and show you some of this, I wanted to show we already had an existing vSphere cluster up and running. It's actually in my home lab. It's 2 very weakly powered like NUC type things. I then used the demo. I will show you how to download the Talos OVA, and we'll leverage that. We'll then create that Talos cluster machine configuration, both for the control plane and the worker nodes. and then we'll create the cluster using that govc, that Golang tool that I just mentioned, and then we'll bootstrap the Kubernetes cluster. We'll then run through a few other areas around making sure that we can leverage the underpinning vSphere environment, the CPI and the CSI for storage, and with that we can probably jump into that demo. Okay, so in this demo, I want to show really how easy it is to deploy something called Talos, which is a Linux distribution concentrated on Kubernetes. So if you're just looking for a distribution to use as a server or as a even as a Linux desktop, then Talos probably isn't your king. Or isn't appropriate. This is really focused on getting Kubernetes clusters up and running. And I found this guide that I'm actually going to contribute back to when I get some chance. Is, well, I have a vSphere cluster, as you can see over here, that we first started on. It's a home lab, so all of the weird and wonderful things that you run in a home lab. As you can see, I have a Minecraft server, all switched off though. But what I want to do is I want to deploy out of the box 3 control planes, 2 worker nodes that can be customized if we want, and I want this to form the basis of my Kubernetes cluster. I also want to deploy our vSphere CSI and vSphere CPI to be able to take advantage of the underpinning storage that I have available to me in my storage. So before we get started, let's jump into here. So the first thing that we need to do is we need to deploy something called govc. So I already have that installed here. As you can see, the instructions on that README will get you through that. So we download that. I've made this directory called Talos vSphere that you can see that I'm in. And again, I'll have a blog post or at least a README to go through this, because you can see that I've got quite a few things going on in here. And some are relevant and some are just logs from me understanding what we need to do. The next thing we need to do is we need to install the Talos CLI. So again, here, I already have that installed. Again, the instructions tell us how to do that. I'm then going to download something called a cp.patch to your local machine, which is what we use to edit that, so our configuration, basically adding in our VIP to our file. And if we take a look at that file, it should be called cp patch. And here I've updated it, so my VIP is on 192.168.169.202. The rest is default, or how it comes. And then from that, we're going to generate some config files for our control plane, and then we're going to in fact, one of the things in the current state is we will also run a Talos CTL gen config. One thing I found, that if you don't specify this argument, then it will use the latest and greatest. And in Talos's version, this is 1.29, so very new release, at least at the time of recording. And actually, some of the stuff that I need is not supported on that yet, namely the vSphere CSI and some other tools that I later want to run here. So I'm putting that argument in that I want it to go back all the way to 1.27.7, which is what I'm using then to enable all of my applications later on as well. And we'll get to that. So then I'm going to point that, or give it a name. I'm then going to point it to my my VIP, and I'm going to use that control plane there as well. And I'm using the force to be able to change the existing one that I already had. And then we can use some Validation steps as per, again, that document that I initially showed to make sure that is valid. And then there's one for our workers as well. So hang on, that won't work because I'm already selected that. But let's just do the worker nodes as well, because this doesn't take very long. All good. Then we need to make sure that we have these environment variables that are mentioned in that document as well. So all our Govc connection details. And if I go down here, and this basically talks through all of that. Then we talk about these setting the environmental variables. Pretty simple stuff. It wants to know your vCenter URL. It wants to know username, password. It wants to know data center, resource pool, and vCenter, data stores, and network. And so I might be being quite blasé around this. I come from a vSphere background. I know many people don't. But one of the things that I find this is going to be a huge benefit to the community is that vSphere is in a large amount of those infrastructures. Maybe not managed by the dev or the DevOps teams, but it might be there. And that means that we can start taking advantage of the CapEx spend, maybe that the business has already taken on. So we can run it alongside of our virtual machines, and we can run Talos there or our Kubernetes cluster alongside that. So that's kind of my thinking behind that. Now, in theory, it doesn't have to be Talos. The reason why I'm choosing Talos is because of the security focus that we have there, and it's a dedicated operating system. We could also look at things like CoreOS and other variants, Rancher, deploy RKE2 or K3S. Again, all depends on what you want to achieve. So then in the guide, we've got choose, but there's two install approaches. We can download this script, or we could run through it manually. But basically, this is where my update will come in the form of a pull request to the project. Is one we use it here. It states a very, very old version of Talos. We're now at 1.1.6, so we want to use the latest and greatest. And I think that might be it. And basically, there's three commands that we can use here with this. One is uploading our OVA to our content library. A content library is just somewhere within vSphere where we can store a copy of a template, if you will, of that. We also then have the create command, and we have the destroy. I've also added, and I'll show you this on mine, is just a timer so that you know how long it takes. And also this is where we can come in and customize what that needs to look like. So if we don't define what that cluster name variable is, then we're going to use VMware test, the version of Talos that we're not only going to use down here to create, but also the for the OVA download as well. And then you can see all the others. So we can define the number of control planes. Default is going to be 3 if we don't specify that as part of the argument. Worker nodes is going to be 2. So we can change that, and you can see the sizes of them as we go through. So with that in mind, if we jump back onto my terminal, and if we do a cat just to take a quick look at what my modified one looks like, and there are some sensitive information in here, but don't worry, it doesn't last long, and it's not very secure anyway. You can't get in to my so I'm exporting as part of the script. I also have them as set as environment variables as well, so that's up to you where you want to store those. As you can see, I'm using 1.1.6. I have defined, you'll see, a vZilla cluster, and I've kept the defaults there on. What I have set is this variable at the top where it starts counting as soon as we trigger that script, and at the bottom there it will print out it took how many seconds to complete. So with that, and this is where I'm probably going to have to speed up the process, but when we hit that create, or we use that create function within that bash script, it's going to launch that control plane. Now, what's happening on our vCenter server already, and while that's doing that, I'll jump into another one just to show you what I'd already done before. But you can see down here, we're deploying that OVF template. Now, before, let's just open another one and let's get over to that. And so we do have the ability to also run that that OVA. I think it's called upload OVA. Sorry, right. So yeah, if we do a VMware and it's called upload OVA. Now what this does is it goes based on that version that you mentioned. It will go and into our vSphere environment. It will go and download, but it will also create this content library that I've defined. And you can see here that I do have that really old version of 1.1 because that's what I started out with, and that's what the that's what the walkthrough talks you to. But now I'm updating it to 1.16, and if I was able to, yeah, here you can see hopefully that this says about 1.1.6. So this takes a while, but you can see that we start deploying. So what we expect to see when you come back is vZilla, well, I'll fast forward things, but you'll see vZilla cluster control plane 1, 2, 3, and then vZilla cluster worker 1, worker 2, because that's what we've defaulted to the script. So with that, let me close this down, and that's going to continue running as we now wait. Okay, and we're back. So you can see that it took a little while to spin up those 5 machines. It does it in like one after the other, which maybe there's a way in which we can throw all 5 at the situation. And if we just come and have a quick look, you can see here that we have 5 machines all powered up. Now, in the process, it wants you to just quickly dive into one of these, and all of them should look pretty similar, right? In that you're going to see the Kubernetes version, you can see the host, you're going to see this IP address. So 192.168.169.35 has clearly been given a DHCP address on my network. You can see that it's in a false ready state. You can see that kubelet is healthy and all of that good stuff. And what we're going to do is we're going to take that .35. Equally, we could go to any of these control planes and get any of those IP addresses, but 35 is good for now. So what I'm then going to do is I'm going to go back to my terminal, and I'm going to clear this, and I'm going to run a Talos CLI command that is going to take that config that we created earlier and we validated, and we're going to bootstrap against that against that 35 address. And if we do that, it's very quick, and it happens. If we dive back into here, what we're going to start to see is stage running, and over time you're going to start to see those reds become greens, and you can already see up the top there we've got 192.168.169.202, and we're starting to see connectivity and all of that good stuff. If we go and dive onto the others, let's just choose 3 for now as well. So that one again is in a stage of running, and this one should be as well, which is one of our workers. So a little less information here. And if we go back to control plane 1, I'm not actually sure how long this actually takes, but if you were to read these, it would give us the feedback on joining the others to the cluster. So just to give you a heads up on where we're going, so while this is doing that, the next stage is, okay, we want then some connectivity into our Kubernetes cluster. So we're then going to use that CLI command to hit our VIP address, and then we're going to pull down that kubeconfig into our file, and then we can start interacting with our cluster. So the one thing that we're waiting for is that ready to change from ready false to, I think, must be ready true, and we're in a good state at that point. Obviously, we're now fighting to get into that desired state configuration. And I'm just going to hit pause and come back onto that. Okay, so just after a little bit of time, you see that our stage is now running. We're ready, true. Our API server is healthy. So what we're going to next do is we're gonna get some of that information about our kube config. So back over to our So this top command is going to use that config again, and it's going to drag it from that VIP, and then it's going to config the node, and then we're going to grab our kubeconfig file. So one thing, obviously I've ran through this multiple times before I record it, so you can see that I'm going to overwrite that VMware test kubeconfig file that we already had. Yes. And with that in mind, we should be able to, now I would normally merge that or at least change what that kube config is. But if we do that, you can see there that we have our five nodes within our cluster. We have our 3 control planes and we have our 2 worker nodes in there. The next thing that we need to do, so that's great and we can start using stuff. But one thing, if we were to go and do a get pods on the kube system, you'll see that we have this VMware tools. So VMware tools is our interaction with the vSphere control plane, and it does some other stuff. There's some information I'll try and find and put in the description, but you can see it's basically a daemon set that lives on each of the nodes that we've just deployed. So with that, we need to deploy VMware tools. So to do that, we can run this command. So again, it hits our 202 config and it adds a secret into that. Sorry, I've already created that secret. Again, these are the instructions that we have in place on that initial web page. And then if we do, if we do a get pods, let's just do a watch on that, because what we should now see is those containers that are created, and maybe we need to kill them and bring them back, but ultimately they should fix themselves if they go through that reconciliation loop, is my understanding at least. I have played around with this very briefly and I've hacked away at it at some points where I have deleted those pods as well. So we're going to wait until that comes up. And if I have to delete it, I'll let you know as well. Okay, so I did go ahead and just delete those pods. And let's now just run that again. And you see already that we're literally up. I don't know whether that will automatically I don't know whether that would be fixed without us deleting. I'm sure it would get to some sort of desired state. Okay, so that's VMware tools deployed. The next thing is we need to deploy our vSphere cloud provider interface. So to do that, we're going to download a YAML file. I'm not going to run this, but basically we're exporting version 1.27. If you remember, I defined 1.27.7. So we're going to use the version of the CPI, which is 1.27. There is one available for 1.28 as well, as I understand. But there isn't one for 1.29. So I've already pulled this down. So if I do a Control C, I do an LS, you'll see here that I already have that vSphere Cloud Controller Manager. And to be honest, this is a few separate things that we're going to deploy in there. It's going to be a service account, a secret, a config map, and then some details around your in fact, let me show you what it is so that you can see. So vSphere cloud controller.yaml. Okay, and if we go up to the top, it contains a few things. So first of all, it's a service account. Second of all, it's a secret, and you can see here that we're defining some stuff here. Now, if you download this is why we need to then edit that file, because we want to define not only our vSphere, our vCenter address, as well as our username and password, but it also gives you them instructions here. And then we're going to create a config map. Again, that config map, we only need to worry about this if you're in a home lab like me. I'm setting it to true, so that means it's not running on TLS. And then the vCenter section, again, just a bit more detail. My vCenter is called VMware Virtual Center. Very creative of me. The server address, the username, the password, and the data center that I'm using. A role binding, a cluster role binding, a cluster role, and a daemon set, and that's it. So with that in mind, we should be able to run the next command, which is applying said file. And you can see here that we've created all of those. Then what we want to do is create a, so that's the CPI configured, and we should, again, if I run, I don't know where the control, I believe it runs in here as well. Yeah, so these controllers run here on the control plane as a daemon set as well, is my understanding. And next up, we need the CSI. So how do we interact with our storage? So with that, we're going to use this command, which is going to pull down a namespace YAML. Basically, it's going to create a namespace called VMware System CSI. And this just enables me to use my underpinning, or the vSphere CSI, on my cluster, which means I can take advantage of snapshots and other such things on there. So we are then going to enforce some pod security rules, and again, I'll make sure that this is documented in a way that stops a couple of warnings when we get to the next phase of interacting with this. The next part is a config file. That config file is something that we use to create a secret within our cluster. Again, the instructions I will include, but if I go and look at CSI vSphere conf, you can see here that from a global point of view, it's a vZilla cluster, virtual center, again, the 181, and the username password 443 in the data center that we're using. And we can go and create a secret based on that. Not like that. We can go and create a secret based on that, confirm that we have that secret. Very good. And in theory, if this wasn't a home lab, you should go and obviously delete that vSphere secret because it contains some sensitive information. I'm not too worried about that in this instance. And then the final thing that we need to do is install the container, or the CSI plugin. So to do that, we take this command, not that, it's because I'm trying to copy and paste. So we're pulling down that vSphere CSI driver version 3 and deploying that. Now, what we will see is those 3 warnings, and maybe that is an issue. Maybe there should just be the one, and it depends on the order that you get those. So what we should be able to do is, if we run, let me clear this actually first, and we can determine what is so what we should see as part of the CSI deployment are 7 out of 7 clusters. Now, obviously, this needs to pull some images down, so I'm not going to be too hasty on sorting that out. I'm also going to check that CSI drivers is what it should be. This is where my rubbish home lab will reflect on how long things take, and we'll probably get a timeout here because I'm trying to pull down all of these images whilst I'm also then trying to interact with that API. That's the same for that long-winded approach of being able to deploy those virtual machines. Is because of the nature of my lab. If you're on something that's using some pretty good storage, then that would also just work. And then CSI node, we should see all of our 5. But let's have a look at our pods. Again, we're pulling down images, so I expect some funky messages like this. Okay, so as you can see here, so what I'm going to do is I'm going to go into that watch, and then I'll come back once that is all up and running. So let's do this. There we go. We're starting to get there now. And the final piece that we want to run through it, well, 2 bits, is one, we need to define a storage class. So as you can see, everything's good stuff. Let's clear this. And so with that in mind, I have a file in here called what have I called it, vSphere storage class. Very simply put, we're going to be using this is the data store that I'm using in my vSphere environment. To get that in particular, if I run over to here, and I grabbed this. So this is just an NFS based volume that is presented from a very old NAS, which is why everything's so damn slow. But this is where I'm storing my virtual machines. It's some shared storage that lives there. So it's using the CSI provisioner. We're calling it example SC. All good. So with that, we can apply that using this command. So pretty simple stuff. And this process, the CPI, the CSI, would be for any virtual machine Kubernetes-based cluster that you're wanting to run on VMware and take advantage of the vSphere CSI. So at that point, we should be all good. And if we go and deploy an example, let's say an example PVC, something like very simple, a 5 gig, we're going to use the storage class of SC. If we deploy that, we should see a dynamic PVC and PV created because of that. So let's apply that, and then let's do a get PVC. And you see there that it's aged 7 seconds and it's already bound on there. Now, if I head over to my vSphere environment, you'll see down here that there's some storage that's already happened. If I was to go to files, we'll see under FCD that new file that we've literally just created. So it's 12.1.24, 536, 536, just to validate that that was there. And if we wanted to just prove that, we could also delete it in the same quick fashion. Head over here, should be gone. FCD, yeah, all gone. Good stuff. And that the only other thing is, if we wanted to get rid of everything, would be to run our script again. Now, could I embellish on that script? Maybe. I think I will personally. Whether the maintainers of Talos want me to, that's a different thing, because obviously there's different versioning and other things that we need to be mindful of there. But hopefully that was useful from a demo perspective. Okay, so hopefully that demo made sense. Probably a bit quick to go over that. I wish I had more time to touch on it. But so what's next? Where do we go now? So that's very easy. I have a vSphere environment. I'm resource constrained. So what can I do next? And where do I want to explore and take this to the next level? So I went out, as all of us technologists do, and I found 3 of these Dell Optiplex. They're 7060s. They have an i5 8500T, which is the low-powered unit. It has 6 cores, 6 threads. One of which of those 3 has a 32 gig of RAM, and the other 2 have 16. I am looking for upgrading that. Then from a disk point of view, we have 256 gig SSD that I've installed, and that is where Talos is actually installed. And then I also have a 512 M.2 NVMe drive in there that is currently not being used. These are all connected into they will be connected into a Dell X1026, which is a managed 24-port switch. Okay, so why? Also, the existing 2-node ESXi or vSphere cluster will also go into this same switch, and this will form a bit of a home lab. I also look on the lookout for another 2 of these units. But really, my focus here is how can we build an API-capable way of being able to spin up multiple Kubernetes clusters using KubeVirt, but also taking that 512 M.2 and having Ceph on there. And then from my only shout out for where I work at the moment is around Cast and K10. How can I then leverage Cast and K10 to protect any stateful workloads that I run between that Ceph environment, that Ceph storage, but also a shared NFS server that I also have available. Hopefully with that was a useful whistle-stop tour of Talos, vSphere, and what I plan to do next as well. So with that, thank you.